15 billion miles from Earth, humanity's most distant machine is quietly dying, one instrument at a time. Not from a crash, not from damage, but because NASA itself just made the call to switch part of it off, on purpose, to keep the rest of it alive a little longer. Stick around, because I'm about to walk you through exactly what just happened to Voyager 1, why NASA had to make this decision, and just how much longer humanity's longest-running space mission actually has left. And hit subscribe now, because this channel breaks down real space news without the exaggeration, and you do not want to miss where this story is heading. To understand why switching off a single instrument on a decades-old spacecraft counts as major news, you first have to understand exactly what Voyager 1 is, and just how far outside the boundaries of normal engineering it has already traveled. Voyager 1 launched from Cape Canaveral in September of 1977, just weeks after its twin, Voyager 2, left Earth on a slightly different trajectory. The mission was originally built around a rare planetary alignment that only happens roughly once every 176 years. A lineup that would let a single spacecraft use the gravity of one giant planet to slingshot toward the next, visiting Jupiter, Saturn, Uranus, and Neptune in a single sweeping tour instead of requiring a separate mission for each one. Engineers at the time called it the Grand Tour, and Voyager 1 and 2 were built to make it happen. Nobody involved in that original mission expected either spacecraft to still be running today. The Voyager program was designed around a primary mission lasting roughly 4 years, just long enough to complete the planetary flybys and beam back the data. Former Voyager project manager John Cassani once put it plainly in a NASA statement, explaining that the team never engineered these spacecraft to last 30 or 40 years. They engineered them not to fail. That distinction turned out to matter more than almost anyone could have guessed, because both spacecraft did not just survive their original mission. They kept going and going and going long after the last planet in their path faded behind them. Voyager 1 flew past Jupiter in 1979 and Saturn in 1980, capturing detailed images of Saturn's moon Titan that helped convince scientists it was worth visiting again decades later. After that flyby, mission planners deliberately sent Voyager 1 on a trajectory that would carry it out of the plane of the solar system entirely, giving up any chance of visiting Uranus or Neptune in exchange for a closer look at Titan. Voyager 2 took the alternate path, going on to become the only spacecraft in history to fly past all 4 giant planets: Jupiter, Saturn, Uranus, and Neptune, a feat that has never been repeated since. Both spacecraft carry something else, something that had nothing to do with planetary science at all. Bolted to the side of each Voyager is a golden record, an actual physical phonograph disc containing greetings in 55 languages, music from cultures across the entire planet, and recorded sounds of Earth itself: wind, thunder, whale calls, a human heartbeat. It was assembled under the direction of astronomer Carl Sagan, on the theoretical chance that some distant civilization might one day intercept either spacecraft long after humanity itself is gone. Whether or not that record is ever actually found by anyone out there, it turned both Voyagers into something more than instruments. They became, almost by accident, humanity's first physical message sent out into the galaxy with no expectation of a reply. In 2012, Voyager 1 crossed a boundary called the heliopause, the outer edge of the bubble of charged particles and magnetic influence that our own sun projects out into space. Crossing that boundary made Voyager 1 the first human-made object in history to leave the solar system entirely and enter true interstellar space, the region between stars. Voyager 2 followed the same milestone in 2018, using a different set of instruments to independently confirm the same kind of transition. Today, according to NASA, Voyager 1 sits more than 15 billion miles from Earth, while Voyager 2 trails behind at roughly 13 billion miles, making Voyager 1 the single most distant human-made object that has ever existed. If you're the kind of person who wants space stories explained clearly instead of buried under jargon, go ahead and drop a like on this video right now, because it genuinely helps this kind of content reach more people who would enjoy it. Here's the part of the story that eventually forced NASA's hand. Both Voyager spacecraft are powered by something called a radioisotope thermoelectric generator, or RTG, a device that produces electricity by capturing the heat given off as a chunk of plutonium-238 naturally decays. There is no way to refuel it. There is no solar panel option this far from the sun, since sunlight out there is far too weak to generate meaningful power. Whatever plutonium was loaded onto each spacecraft back in 1977 is the only fuel either one will ever have, and it has been slowly, steadily decaying for essentially 50 years now. According to NASA, each spacecraft's power output has been declining by roughly 4 watts every single year, a slow, predictable drain that engineers have been tracking since launch. As of 2026, Voyager 1's generators are producing less than half the power they originally delivered when the mission began. That shrinking power supply has to cover everything on board: the transmitter that sends data back to Earth, the heaters that keep instruments and fuel lines from freezing solid in the extreme cold of deep space, and the handful of scientific instruments still gathering data nearly 5 decades after launch. Every year there is simply less power available to go around, and every year mission engineers have to decide what stays on and what has to go. This was not a decision made in a panic. According to NASA, mission engineers sat down years in advance and worked out, in detail, the exact order in which they would eventually shut down onboard systems, carefully sequenced to preserve as much unique scientific capability as possible for as long as possible. Each spacecraft originally carried 10 matching sets of instruments. Over the decades, several were switched off simply because their job was finished. Instruments built specifically for photographing planets, for instance, no longer had anything left to photograph once the spacecraft were traveling through the emptiness beyond Neptune. Others have been shut down purely to save power, following that pre-planned sequence. By early 2025, 7 of the original 10 instrument sets on each spacecraft had already been powered down. In February of 2025, engineers shut off Voyager 1's cosmic ray subsystem. The following month, in March of 2025, they shut down the same instrument on Voyager 2, an experiment called the Low Energy Charged Particles Instrument, or LECP, which measures charged particles including ions, electrons, and cosmic rays drifting through the space around the spacecraft. That left Voyager 1 as the only one of the twins still running its own version of the LECP. Then, on April 17th of this year, according to NASA's Jet Propulsion Laboratory, that changed. Engineers sent a command to Voyager 1 to shut down its own LECP instrument, the same one already retired on its twin more than a year earlier. Because Voyager 1 sits so incomprehensibly far from Earth, that command did not arrive instantly. Radio signals travel at the speed of light, the fastest speed anything in the universe can move, and even at that speed, NASA reports it still took roughly 23 hours for the shutdown command to physically reach the spacecraft. Once it arrived, the shutdown sequence itself took a further 3 hours and 15 minutes to fully complete, according to NASA, a slow, careful process for an instrument that had been running almost continuously since 1977. Here is the detail that tends to stop people in their tracks once they hear it explained. Engineers did not shut off the entire LECP system. A small motor inside the instrument, responsible for slowly rotating its sensor so it can scan in every direction, was deliberately left running, according to NASA, because it draws only about half a watt of power. It is not doing any active science on its own right now. It is being kept alive purely so that if extra power somehow becomes available down the line, engineers retain the option of switching the full instrument back on. It is a small, careful hedge against an uncertain future, built into a machine that is already operating decades past anything its original designers ever expected. Voyager mission manager Kareem Badarudin at NASA's Jet Propulsion Laboratory addressed the decision directly in a NASA statement, saying that while shutting down a science instrument is not anyone's preferred outcome, it remains the best option currently available. According to that same statement, Voyager 1 now has exactly 2 operating science instruments left, one that listens to plasma waves in the surrounding interstellar medium, and one that measures magnetic fields, both of which, according to NASA, are still functioning well and continuing to send back data from a region of space no other human-made object has ever explored. It is worth pausing here to explain why NASA cares so much about squeezing every possible extra day out of a spacecraft this old, rather than simply accepting the mission is winding down. Voyager 1 and 2 are not just old, they are irreplaceable. In a very literal sense, no other spacecraft currently exists anywhere in interstellar space. Every modern probe humanity has launched since, no matter how advanced its instruments, is either still inside the solar system or still traveling toward its edge. The data both Voyagers continue sending back describes an environment, the actual physical space between stars, that no other instrument built by human hands has ever directly measured. If both spacecraft eventually go silent for good, there will be no possibility of gathering equivalent data again until a future mission, likely decades away at minimum, manages to travel that same enormous distance. Picture for a moment exactly what Voyager 1 is experiencing right now, because the scale of it is almost impossible to hold in your head all at once. It is currently traveling through space at over 38,000 miles per hour, far faster than any bullet ever fired, and moving farther from Earth with every second that passes. It is so distant that sunlight, traveling at the fastest possible speed in the universe, takes over 23 hours just to reach it, meaning if the sun blinked out of existence entirely right now, Voyager 1 would not know for the better part of a day. It carries a golden record built to outlast every language currently spoken on Earth, a physical artifact, under NASA's own estimates, capable of surviving. Intact for well over 1 billion years, drifting silently through the vast, mostly empty space between stars, long after the spacecraft carrying it has gone permanently silent. If you have found this as fascinating as I did while researching it, drop a comment letting me know, because it genuinely helps me figure out what other space stories are worth covering next. So what happens next, and how much longer does Voyager 1 actually have? According to NASA and outside estimates, the spacecraft's dwindling power supply means more instruments will almost certainly need to be shut down in the coming years, following that same pre-planned sequence engineers worked out long ago. Some mission estimates have suggested Voyager 1 could potentially keep at least some instruments running into the early 2030s, before power finally drops below the minimum threshold needed to operate anything at all. Even after every remaining science instrument is eventually switched off, engineers may attempt to keep the spacecraft's transmitter alive for as long as possible afterward, purely to confirm the spacecraft is still out there, still functioning, even with nothing left to say. It is worth being honest about how uncertain that exact timeline really is. Nearly 50 years past its original design life, Voyager 1 has already outperformed essentially every expectation anyone involved in building it ever had. Components have failed unexpectedly before and been worked around through creative fixes radioed across billions of miles, sometimes involving computer code written literally decades earlier than the problem it was eventually used to solve. Nobody, including the engineers currently managing the mission, can say with total precision exactly when the very last signal from Voyager 1 will arrive. What they do know with much greater certainty is that whatever time remains will be spent exactly the way it has been spent for the past several years, one careful, deliberate power-saving decision at a time, squeezing every last watt out of a machine that was only ever supposed to last 4. Here is the detail that tends to stick with people longest after they hear this whole story laid out. Somewhere on the current staff at NASA's Jet Propulsion Laboratory are engineers who were not yet born when Voyager 1 first launched in 1977, now personally responsible for keeping a spacecraft older than themselves alive and talking, one shutdown command and one 23-hour radio delay at a time. The mission was built to last 4 years. It has now been running for nearly 50. And even as its instruments go dark one by one, it continues, for now, to do something no other human-made object in existence can do: send back a direct, physical signal from beyond the edge of our entire solar system. If stories like this one, grounded in real reporting rather than exaggerated headlines, are what you want more of, subscribe to this channel and turn on notifications, because Voyager 1 is still out there, still transmitting, and there's a real chance the next update on this mission arrives sooner than anyone expects. Thanks for watching, and I will see you in the next one.